Hey everyone, I'm Evgeny or Eugene, and I'm currently working at FastNEAR. So today's talk going to be called Illusion of Speed, and I will talk more about what we can do to improve the actual illusion, not real blockchain, because that's what Bowen is doing. So let's start first. So blockchains are slow, and the reason for this is they're blockchains. So they built on top of blocks, and the blocks takes time to produce. So we cannot actually avoid this limitation, even so soon maybe blocks going to be shorter. So what we can do is to make sure that the rest of the interactions are actually faster. So what we're going to talk today about is first, what you can do about your website, about data loading, then wallet signing, and finally about transaction. That's going to be the biggest part. So let's first start with how to build a fast website. So that's mostly outside of this talk, but the main thing you can do is just make sure that the website loads faster. So you can use an edge network, something like Cloudflare. You can cache your content, especially static content, so it doesn't have to come from your server. You can make sure that your initial page spawns faster, so then minimize the size of the code and stuff like this. And finally, the most important piece, you don't want to block your UI on data. So make sure it loads, and you are not loading something don't display a spinner. So next, let's talk about how you can load data faster. And first thing is don't block the UI on spinner. That's the most important. So when you call the RPC and loading 5,000 requests, users just waiting here. So don't do this. You can cache the data that you previously loaded. So if it's not a cold start, you can load it from your local storage, for example, from the browser. And then you can reuse this data while the new data is loading, so revalidating it. So don't rely just on RPC. So don't fetch all the data from RPC. Use indexers and APIs and just statically store the content. The next thing is when you load the data, so imagine Ref Finance, it loads all the pools that exist there in order to just display the UI. You don't need to do this. So finally, you can also try to minimize the time where you need to load the data sequentially. So for example, all right, let's load the account ID. Then from this account ID loads the list of all the tokens the account has. And then after that, we can load every single token and maybe a metadata for each token. So it's slow. So try to parallelize this if you can. And final piece of advice, use FastNEAR RPC and API, and you will cut some latency there. So the next piece is going to be wallet sign-in. And there are also a few considerations you can do when you're building an app. So first thing you can do is just don't block the UI and wait in a wallet selector, and just cache, for example, the account ID locally. So in Near Social, when we're building it, one of the things we noticed is wallet selector spawn time was about 1.5 seconds. So imagine you already loaded your static page, and then you're trying to get the account ID in order to display a profile picture. So that process was taking 1.5 seconds while you already know the account ID because the page was opened before. So just get the account ID from the storage, local storage, and display it immediately. Also, wallet selector is pretty large because there's a ton of wallets there. So every single wallet has some code that is integrated. So maybe what you can do is just load the code lazily and don't load it immediately, when the page starts. Finally, well, not finally, but one important piece is when you ask user to sign in into your app, often you don't need a limited access key. So for financial applications, most of the time, you don't really need to get a limited access key towards a certain contract, because every time you swap, you attach one Yoctanir, and it goes to the wallet, and you sign transaction in the wallet. So you don't really utilize the limited access key. And you can also just use the signature. So instead of, if you need to authorize the user, you can just ask for the offline signature. So that's what, for example, NEAR AI does. Instead of getting the limited access key, you can just ask, sign some message, and then when they do this, you can verify that the message was signed by the actual user, and by verifying their keys. So now we get to the actual important part of the talk, is how to make transactions faster. And you cannot really. Blockchains are actually slow, so you cannot really make your transaction faster. But what you can do, you can make user to not feel like they're slow. So don't block the UI waiting for a transaction. So that's very common right now. Whenever you go to the wallet and you do some transaction, it just shows you a spinner of the transaction getting executed. And you wait for the whole thing it executes, and often for the finality, and maybe even for gas receipts. So it takes a while. Or you execute in some other transaction on the front end, and it's also slow. So what can you do? So don't block the UI when you have a limited access key. So limited access key allows you to execute transactions in the app directly without going to the wallet to sign it. So you can do a few things. First, you can just pretend the transaction already happened. That's what Berry Club did in the past. When you draw something on the board, it just pretends that you already did it. And it renders like you already did it. And you don't wait for confirmation of the transaction until it's completed. Next, you can show notification. So for example, you can show a pop-up. That's what mem cooking is doing. They actually displaying that, oh yeah, transaction is executing. And you don't block the experience. Finally, you can display some animation, but just don't use the spinners that are blocking UI. Instead, you can display something like, oh, there's a heart jumping. So when you liked something on NEAR Social, instead of blocking it completely, just displayed small animation there. Now we get to the part about Transaction API. So that's what we wanted to announce from FastNEAR. That's a new thing that we are working on, and it's coming soon. So what are we solving with this new Transaction API? So first thing, thanks to Bowen and the team from NEAR 1, now we have the first problem to solve where RPC can just decline your transactions. Oh yeah, shard is congested, sorry. And you're like, what? I just signed transaction, send it to you, and you're like, yeah, congested. No. So next, thanks to chain signatures, the transaction actually can be very slow. So you send a transaction, and it's just sitting there waiting for chain signature through yield resume mechanism. And then RPC is like, oh yeah, timeout. 10 seconds is gone, your transaction didn't execute, sorry. So it's a problem right now. Next, transaction can be very old, so longer than, for example, 5 epochs of RPC, and then RPC will just say, oh yeah, it doesn't exist. I don't know, cannot find it. And finally, the biggest problem is you block the UI, so don't block the UI. And we're gonna solve it. So here's how you can solve some of this with Transaction API. First, we're gonna auto-retry the transaction. So you send it to us, we take care of it's getting included in a block. So if you cannot include it immediately, we will retry to the next block until the congestion is done. Next, we give you a live status of the transaction. So if transaction is executing, we'll notify you while it's going. We're also going to handle all the historical transactions. So it's not only one epoch anymore, it's entire blockchain history. So you can query any transaction. finally, one of the cool stuff, we will give you a human-readable status of the transaction. So you can display it while you waiting for it. And instead of just a spinner, you can notify like what's actually happening. And that's a unique part about NEAR protocol because our transactions executes in multiple blocks. So they execute on multiple contracts, and the transaction is just not one piece, but actually multiple items. So for example, we'll go through this actually. And then finally, it's going to be faster than RPC because we'll cache it, and you don't need to run NEAR core in order to do this. So let's look at the example of what we mean by human-readable status. So let's look at the simple swap example through ref finance. As you know, that transaction takes about maybe 5 to 6 blocks. And the reason for this, it needs to go through multiple contracts. So the first status that you will get when you use our API is we actually received your transaction. And we'll tell you, all right, here's the next status. So that's optional. You don't need to display it to the user, but you can use it if you're interested. And like, oh yeah, next status will likely include this in the block. So the next status update is, okay, transaction was included in the block, and your account was charged the gas fee. So next operation, we're going to go and call USDC contract. So when we call USDC contract, we can understand what's happening, and we can say, all right, we just charged 100 USDC from your account, and now we're going to call ref finance. Now we swapped on ref finance, and we know what's going to happen next because we know the receipts that coming out of this execution. So one of them is we're going to call USDC. We're going to call, for example, FastNEAR, and we're going to schedule a callback back to ref. Then we finalize in USDC call, and in parallel of this, we actually transfer in U10 FastNEAR from ref finance. And the next we're going to call ref is the callback. Okay, finalizing the swap, so all successful. No need to do token refunds or anything like this. So we're pretty much done. So a transaction will give it to you, or like our API will give it to you that transaction is completed. And next is going to be like gas refunds. And finally, we're going to get the finality. So the API will give it to you all through very simple standard polling interface. And it's kind of like how you would use similar to WebSockets, except where it will just push it to you with the like event source on JavaScript. All right, and I think my slides got messed up a bit on the order, but we're going to talk about what if you have transaction right now, what can you do to avoid blocking the UI in the transaction. So first thing you can do is you can send the transaction using the method sendTX, and then you can specify a parameter, a new parameter on RPC called wait until. So this parameter specifies what RPC should do. And it has two options for you. One is included. It means the transaction was just included into the optimistic block. And included final is actually the transaction was included into the final block, like with finality. So it's not going to wait for the whole status of the transactions, but it's going to wait until just like you were charged for the gas. So, and then it immediately returns you the result that what happened. So that's important because you don't want to like your status to wait 10 seconds or more for the full transaction to complete. So you want to know that the transaction was included and then you just want to give the control back to the application or to the wallet. So the second piece, when you query the status of the transaction, you can also use wait until and specify none. And that parameter will return you the result, like the status immediately, the current status. It's not going to wait for anything. It will just say, OK, transaction, for example, completed 5 receipts, but didn't complete entirely. So you can call it multiple times while the transaction is executing. And with the new transaction API, it will be like automatically given to you. So you can read more about this on the docs. And that's actually the best source of the information for the current status of the transactions. So stay tuned for our API. And thank you.